Hello students, my name is Saki Bijaz and I'm your course instructor for mobile and wireless communication networks. Today our topic is WiMAX. The content for this topic is we'll study about what is WiMAX, we'll talk about the standards that we are using in WiMAX, we will have an understanding of WiMAX, and in the end we will have a summary about WiMAX. So let's start with WiMAX. What is WiMAX? WiMAX stands for Worldwide Interoperability for Microwave Access, and it is responsible for certifying broadband wireless products for interoperability and compliance with the standards. This is the diagram, or you can say the connection diagrams for WiMAX. In this WiMAX, we have two type of connections, point to point and point to multi-point. As you can see in this figure, that BS are connected. They have a point to point access and they have point to multi-point, multi-organization access with the different organizations. Okay, so let's continue with WiMAX. WiMAX steadily rolling out globally and has been launched in several countries. Initially, WiMAX developments are likely to be for fixed applications, but now they are varying. Full potential of WiMAX is released only when used for innovative, nomadic, and mobile broadband applications. And the main competitors for mobile WiMAX are cellular systems. So that's WiMAX and cellular systems. Let's continue to WiMAX. First step towards mobility. It has an add-on of nomadic capabilities to fixed broadband. For example, users can move from one location to another location. However, may not allow for seamless roaming and handover at vehicular speed. Allow pedestrian speed, mobility, and connectivity to then at work from locations within the coverage areas. WiMAX is based on the IEEE standard, and we call it WMAN standard, developed by the IEEE 802.16 work group. It was adopted by both IEEE and ETSI Hyperman group. Standards are based technology supporting wireless broadband class access, enabling wireless data delivery. So the target for this standard is fixed wireless broadband as an alternative to wired broadband access, for example, cables and DSLs. Mobile broadband offers the additional functionality of portability, nomadicity, and mobility. So WiMAX offers point-to-point connectivity. In point to point, it says a line of sight, a range of 30 kilometers, 30 miles, or 48 kilometers. Theoretical throughput up to approximately 75 megabits per second for both uplink and downlink. It serves as a backhaul network. Okay, point to multi-point (PMP). It has a non-line of sight, range up to 5 miles or 8 kilometers. It connects residential or business subscribers to base station. Comparison of WiMAX to other competitors. It has parameters fixed WiMAX, mobile WiMAX, HSPA, Wi-Fi. So we can see the comparison between WiMAX and other competitors using these parameters. It shows the standards and peak downlink data rates and peak uplink data rates between all these fixed WiMAX, mobile WiMAX, HSP, and Wi-Fi. And the point to be noted is using 2x2 MIMO and 10 megahertz channel in efficiency of CSMA, MAC, the layer 2 throughput performance is usually above 20 megabits per second to 25 megabits per second. The same other parameters that we can see the comparison between WiMAX and other competitors are modulation, multiplexing, duplexing, frequency, coverage, and mobility. So all these factors have included in this chart, so you have to look at that. Okay, now let's talk about the standards. So we know that it's 802.16 standard that we are using in WiMAX. We'll study in the next slide about standard. So IEEE 802.16 workgroup was formed in 1998. The objective was to develop as standard for WMAN, wireless metropolitan area network, wireless MAN. Uh, it was focusing on LOS based PMP wireless broadband system in the 10 GHz to 66 GHz band. WiMAX Forum established in June 2001. December 2001, IEEE 802.16 standards for more than 11 GHz completed, and we call that WMAN S. So in January 2003, 802.16a, another update was completed. It was extended to support licensed and license exempt frequencies for NLOS applications. For example, 2 GHz to 11 GHz range. OFDM scheme included as a part of the PHY layer to support in multipath environment. Additional MAC functionalities defined support OFDMA in September 2004. Further revision completed, and IEEE 802.16 or 2004 was approved. It replaces 802.16 that was introduced in 2001, 802.16a and 802.16c, adopted as a basis for Hyperman high performance metropolitan area networks developed by ETSI. In December 2005, IEEE 802.16e was launched and was completed. Supporting of vehicular mobility applications, further modifications to MAC layer to support high-speed mobility. Vibro systems developed by Korea's ETRI Electronics and Telecommunication Research Institute are completed with 802.16e update and mobile WiMAX. Vibro supported at a rate from 512 kilobits per second to 3 megabits per second, launched in June 2006. In May 2009, revised IEEE 802.16 was approved. It was replaced 802.16 that was introduced in 2004. Incorporates 802.16 2004 and towards then update the new one. In 19 October 2007, WiMAX officially part of ITU's family. That was in IMT 2000, and that link is given which shows you about this information. So summary of current 802.16 standards. That 802.16 was when it was launched. What was the frequency band, applications, MAC architecture, transmission scheme, and modulation. So we have 802.16, 802.16 that was in 2014, and 802.16e that was launched in 2015. So all the comparison in this summary. Another, it was gross rate, data rate, multiplexing, duplexing, air interface designations, WiMAX, and implementations. All these, the three standards have all these differences shown in this table. So wireless human, wireless high-speed unlicensed man, that we call a human, is similar to OFDM PHY physical layer, but mandates dynamic frequency selection for license exempt bands. Okay, now we'll understand what is WiMAX. So definitions of WiMAX are the base station, a centralized equipment that provides connectivity, management, and control of the subscriber stations. We call that SSS. Subscriber stations, the equipment that provides connectivity between subscriber equipment and the base station. Service flow unidirectional. A MAC transport service provide for transmission of UL and DL, uplink and downlink traffic, and is a key concept of the quality of service architecture QoS architecture. Each service flow is associated with a unique set of QoS parameters such as latency, jitter, throughput, and packet error rate that the system strive to offer. Some of the attributes of service flow are service flow ID, we call that SFID. This is a 32-bit identifier that uniquely identifies the service flow to the SS. Connection ID, CID, a 16-bit value that identifies a connection to equivalent pairs in the MAC of the BS and SS, base station and subscriber station. Maps the SFID, which defines the quality of service parameters of the service flow associated with that connection. A MS can have more than one CID at a time, one primary CID and multiple secondary CIDs. MAC management and signaling messages are transported through the primary CID. Provisioned QoS param set, admitted QoS param set, active QoS param set, and authorization module. Uplink map asset of information that defines the entire access for the schedule interval. Downlink map, a MAC message that defines burst start time for both TDM and TDMA by a subscriber station on the downlink. SAP, service area, service access point, a point in a protocol stack where the service of a lower layer are available to its higher layer. Service data unit, the data unit exchanged between two adjacent protocol layers. Downward direction, data unit received from the previous higher layer. Upward direction is a data unit sent to the higher layer. As you can see in this diagram, we have two type of identities, sending identities and receiving identities. We have a number of layers, and it's all about telling you how SAP works. So you can say PDU and SDU in our protocol stacks are designing something like this. Summary of MAC functionalities. MAC layer is responsible for some important functions. Segments or concatenate of the service data unit, SDUs we call them, into the MAC PDU protocol data unit. Selection of appropriate burst profile and power level to be used for PDU's transmission. This transmission of PDUs that were received erroneously by the receiver of ARQ. ARQ stands for Automated Repeat Request is configured. It provides QoS control and priority handling of the PDUs. It's scheduling of PDUs over available physical layer resources. Also to provide mobility management for support for upper layers, security and key management, power saving mode and idle mode operation. So these all are the functionalities that Mac actually performs.